Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 13, comparing irrational numbers. Okay. Irrational numbers means they cannot be represented as a ratio. This is rational. This is irrational. Or is it? Anyway, here we go. Rodney thinks that the cube root of 64 is greater than 17 quarters. Sam thinks that 17 quarters is greater. Who is right and why? So what we want to do is find out what the value of the cube root of 64 is. And this is how I present simplifying cube roots. I take 64 and I do a factor tree, and I always factor out the smallest prime number, which would be 2, and that would be 32, and then 2, and half of 32, or 32 divided by 2, is 16, and then that would be 2, and that would be 8, and this would be 2 times 4, and finally 4 is 2 times 2. Now, when we're talking about cube roots, that is called the index. This is the index. And the index tells us how many 2's we need, or how many numbers we need under the radical to equal 1 outside. And let me explain that. If I have the cube root of 8, that equals the cubed root of 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And since I have 3 2's, then the cubed root of 8 is simply 2. So if I have a group of 3 of something, they become 1 outside. And that's what the index tells us, how many groups of these numbers are required to take out and become 1 outside of the root symbol. So the cube root of 64 has 3 2's, but then it has 3 2's again. So that means the cubed root of 64 equals the cubed root of 2 cubed times 2 cubed. Well, that would equal 2 times 2, because I have 3 2's, and therefore the cubed root of 64 is 4. Now 17 quarters, on the other hand, 4 goes into 17 4 times. 4 times 4 is 16, with a remainder of 1. So the cubed root of 64 is 4, and 17 quarters is 4 1/4. Rodney thinks that the cubed root of 64 is greater than 17 quarters, and Sam thinks that 17 quarters is greater. Well, 4 1/4 is greater than 4, therefore 17 quarters is greater than the cubed root of 64. So who is right? 17 quarters is greater. Sam is correct. Okay, so this is called comparing irrational numbers, the first exploratory challenge. It's dealing with all rational numbers. I'm confuzzled, but anyway, we'll continue. All right, number 2, which number is smaller, the cubed root of 27 or 2.89? And here's what it would look like on the number line. The cube root of 64 is 4. 17 quarters is to the right of that, making it greater. Number 2, which number is smaller, the cube root of 27 or 2.89? Okay, so if I continue with showing you the way I do cube roots, that is a perfect cube, by the way. But if I didn't realize that and I took 27 and made a factor tree, that'd be 3 times 9, and 9 is 3 times 3. And since my index is 3, that means I need 3 3's, 3 of something from my factors to become 1 outside. So the cube root of 27 equals the cube root of 3 cubed, and since the 3 cubed and the cube root cancel, that's equivalent to 3. So 2.89 is obviously less than 3. So 2.89 is less than 3. Therefore, 2.89 is less than the cube root of 27. Okay, number 3. Which number is smaller? The square root of 121 or the cube root of 125? So if I do a factor tree of 121, that is 11 times 11. And since it's a square, that would be assumed to be a 2. Your index isn't there, it's a 2. I need 2. So the square root of 121 equals the square root of 11 times 11, which is 11. Now if I do the cube root of 300 or 125, then I do a factor tree of 125 over here, factor out the smallest number that will go into it. 5 goes into 12 2 times with a remainder of 2. 5 will go into 25 5 times, and 25 is 5 times 5. I have 1, 2, 3 5s, and I have a cube root, so that equals the cube root of 5 cubed, or 5 times 5 times 5, which is 5. So in answering the question, 11, which number is smaller? 5 is less than 11, so therefore the square root or cube root of 125 is less than the square root of 121. Number 4, 49 is 7 times 7, and it's a square root, so I have 2 7s. So the square root of 49 equals the square root of 7 squared, which equals 7. The cube root of 216 is 2 times 108, which is 2 times 54, which is 2 times 27, which is 3 times 9, which is 3 times 3. Okay, so I have 3 2s, and I have 3 3s. So the cubed root of 216 equals the cubed root of 2 cubed times 3 cubed, which equals 2 times 3, which equals 6. Which number is smaller? Well, 6 is less than 7. Therefore, the cube root of 216 is less than the square root of 49. Okay, we're all the way up to number 5, and we finally got to an irrational number. So far, 1 through 4 was dealing with all rational numbers. So now I have the square root of 50 and 319 divided by 45, and want to know which number is greater. So I'm going to do a factor tree for 50, which is 2 times 25, and 25 is 5 times 5. And it's a square root, so I need 2 to come outside. So the square root of 50 equals 5. And if we don't have 2 of something, then they are remainders left underneath the radical. So 50 reduces to 5 square root 2. So we're still dealing with an irrational number with a radical. I cannot simplify the square root of 2, but I know that 5 square root 2 is the square root of 50. And perfect squares are 49, 7 times 7, and 8 times 8 is 64. So if I had a number line with 7 and 8 here, which is the square root of 49 and the square root of 64, I know the square root of 50 is down here near the square root of 49. It's right next to it, so it's 7 point something. Okay, so now I know that 5 root 2 is 7.1 or 2, somewhere around there. Okay, so now we're going to simplify 319 over 45 by doing long division. So I take 45, and I see how many times 319 it will go into 319. 45 will not go into 31. 45 will go into 319. Well, that's almost 50, so I'd say 6 times. 6 times 5 is 30. 6 times 4 is 24, plus 3 is 27. subtract and get 949, so it's 7. So let me just undo all that. And let's put a 7 there. 7 times 5 is 35. 7 times 4 is 28, plus 3 is 31. Subtract and get a remainder of 4. Bring down a 0. 45 will not go into 4, so I bring down another 0, 400. And I would say maybe 8. 5 times 8 is 40. 8 times 4 is 32, plus 4 is 36. And 400 minus 360 is 40. And so now that's going to keep repeating. So it's going to be 7.08 repeating. So now I need to simplify this more. I need to find out where that is exactly, because I know that 7.08 is close to 7 as well. So if I refer back to a previous lesson where we're simplifying radicals, well, where is the square root of 2? Between two perfect squares, 1 and 4, but it's closer to 1. Okay, so if I want to see if it's between 7, and now I want to see if it's less than 7.1 or more than 7.1, so I'm going to square 7.1, which is the same as 7.1 times 7.1. And I get 50.41. So that's just a little bit more than square root of 50. So the square root of 50 is between 7.0 and 7.1. Okay, but this is 7.08, so I need to go out a little further. Okay, so now I want to see if it's between 7.0, I want to see what 7.08 squared is. So if I take 7.08 times 7.08, 8 times 8 is 64, 7 times 8 is 56. Okay, then bring down my spacer, and then 0, this is all just going to be zeros on this row, bring down 2 zeros, 7 times 8 is 56, and 7 times 7 is 49, and I get 4, 6, 12, 11, 10, 50, and 4 decimal places. So 7.08 is 50.1264, but 7.1 is 50.41, and the square root of 50 is less than 50.1. So therefore, the square root of 50 is less than 319 over 45. Okay, we're not doing this yet. Okay, so we simplified this down. We tried to find this out. So 7.1 squared was 50.41. And 7.08 is 50.12. So the square root of 50, so 7.08 is the square root of 50.1264, which is more than 50. Okay. Okay, this one is dealing with a repeating decimal and then 5/11ths. And what is 5/11ths? So if I did long division with 5/11ths, then it is 0, 4. 11 times 4 is 44. Subtract and get 60. 5 times 11 is 55. 60 minus 5 is 40, or 4. 60 minus 55 is 4, bring down a 0, so it's 40. No, it's not, it's 50. 60 minus 55 is 5, bring down a 0, 50. 11 will go into 50 4 times, so now we're repeating. So 11, 5 divided by 11 is 0.45 repeating. And So in expanding both of these, 0.4 repeating means 0.444 forever. And 5 over 11, we just found out, is 0.4545 forever and ever. Now, if we just focus on these first two decimal places in each number, 45 is greater than 44, so 5/11 is greater than 0.4 repeating. Number 7. Okay, first I'll do the fraction. Well, there's 4 25s in 100, and there's 6 in 150, so it's going to be 6 times 25 is 150, and that will leave me with 4, bringing down to 0, 40, 1, 25, subtract, get 15, bring down to 0, 25 will go into 150 6 times. So it's 6.16. All right, so 154 over 25 equals 6.16. The square root of 38, okay, since I'll do a factor tree first, that's 2 times 19, and 19 is not a perfect square, and it's prime, so that's the end of my factor tree. I don't have any pairs, so I cannot simplify the square root of 38. So now I need to focus on the square root of 38, and 6 times 6 is 36, so the square root of 36, and 7 times 7 is 49, so square root of 38 is between the square root of 36 and the square root of 49, so therefore 6 square root of 38 is between 6 and 7. But so is 6.16, so we need to take this a little bit further. Now 38 is only 2 away from 36, and it's 11 away from 49, so I would say square root of 38 is close to 6.1, so I'm going to check what 6.1 squared is. And that's 1, 6, 0, 6, 36, 1, 12, 7, 3, 2 decimal places. So the square root of 61 is 37.21. So square root of 38 is more than the square root of 37.21. So 6.1 is less than the square root of 38. So now we're going to try 6.2. 2 times 2 is 4. 6 times 2 is 12. 0, 6 times 2 is 12, 6 times 6 is 36 plus the 1, and we get 4, 4, 8, 3. Well, 2 decimal places. 38.44 is more than 38, so 6.2 is more than the square root of 38. So square root of 38 is between 6.1 and 6.2. And we have 6.16. That is still between 6.1 and 6.2, so we still haven't proven where this lands, so now I have to go out another decimal place. Okay. 38.44.21, what's it closer to? 37.21, that's 79/100ths away from 38, and this is 44, so it's closer to 6.2, so I'm going to try something above 5. And it's going to be a little bit more than 5, so it's, do I try 6 or maybe 7? I'll try 6.7 first. So I'm going to take 6.7 times 6.7. 7 times 6 is 42, and 4 is 46. 0, 7 times 6 is 42, and 40, and so this is 40, 9, 8, 4, 4. So it's 44.89. Okay, and then I'll do 6.8. Let me just put them side by side. And change colors. So now I'll do 6.8. So 44.89 is more than 3.8. So I don't want to do 6.8. So let's put this back. So 44.89 is more than 38. So I want to go the other way. So I'll try 6.6. Okay. 43.56 is still more than 38. Okay, these numbers are both too big, and there's a good reason for it. I'm forgetting my decimal places. I did 6.1, I did 6.2, but then I jumped all the way up to 6.6 and 7, which I should not have done. It should be 616 and 617. So if I do this again, my apologies there, I forgot my hundredth. So I want to try like 6.16 times 6.16. Six point 16 is 37.94, which is less than 38. So I'm guessing 6.17 will be more than, and we found what 200ths were in between. 7 times 7 is 49, and so on. Okay, so we broke it down to 6.16 is less than the square root of 38 is less than 6.17 because 37.9 is less than 38 and 38.06 is more than 38. So I know that the square root of 38 equals 6.16 something. And it doesn't matter what that something is, it's going to be more than 6.16. So this says which number is greater? The square root of 38 is greater than 154 over 25. Okay, so now you're probably saying to yourself, why is he doing all this work when all you got to do is plug it into a calculator? Well, if you just keep plugging things into calculators, you're not going to get a feel for number theory and how things work and developing your mental ability to problem solve. Just pushing buttons is no way to get through math. So you need to learn these procedures for future courses as well. So number 8 says which number is greater, the square root of 2 or 15/9? So of course I'll do the easier one first. 15 over 9 equals 9 into 15 one time. And that will leave me with 6. 9 times 6 is 54. And it repeats. So it's 1.6 repeating. Okay. So the square root of 2, what numbers are those between? The square root of 2 is less than the square root of 1, and it's more than the square root of 1 and less than the square root of 4. I'm looking for perfect squares first. In other words, it's between 1 and 2. Okay, doesn't help us much. So is the square root of 1, or so is 1.6. Repeating, it's between 1 and 2. So now I have to go out another tenth. Okay, so since I have to go out to another decimal place, 2 is 1 away from 1. 2 is 2 away from 4. So it's closer to 1. So I would start with maybe 1.3. So if I take 1.3 squared, which is 1.3 times 1.3, I get 1.69, which is less than 2. And if I take 1.4 and multiply it by 1.4, which is 1.4 squared. Four times 4 is 16. 4, 5, 0, 4, 1. 6, that's a 4, 9, 1, 2 decimal places. 1.96 is less than 2, so it's not 1.3. It's between 1.4, or it's higher than 1.4. I don't know if it's between 1.4 and 1.5 or not. So the next thing we're going to do is check 1.5 squared. Well, that's 2.25. I already know that because I know my multiplication table is 15 times 15 is 225. So now I know that it's between 1.4 and 1.5. So the square root of 2 is less than 1.5, so therefore it's less than 1.6. So 1.6, or 15/9, is greater than the square root of 2. Number 9, place each of the following numbers as its approximate location on the number line. Okay, so the square root of 25 is 5, so I'm going to put that right there. So that one's done. And the square root of 28, square root of 30. So what should we do here is take these numbers on the number line and square them and see if we get a number that's close to this. So I'm going to take the 5.1 times 5.1, which is 1, 5, 0, 5, 25. Bring that down 1, 10, 6, 2 decimal places. So 5.1 is squared is 26.01. So the square root of 26.01 is 5.1. So since I have 28, that's more than 26. It's greater than 5.1. So I will continue. 5.2 times 5.2. So 5.2 squared is 27.04. So we're greater than 5.2. So there's no values between here and here because these are in order of least to greatest already. And I know the square root of 36 goes at the end here because that is 6. Okay, so that one's done. So we just need to find these. So I already know the square root of 28 is more than 5.2. So now we're going to do 5.3 squared. 3 times 3 is 9, 15, 0, 15, 25, and the 1 is 26, 9, 10, 6, 7, 8, 28.09. So it's just a little bit more than 5.2. So right here is the square root of 28. Somewhere between, actually 5.3 is more than 28, so I've got that on the wrong side. It's a little bit less than 5.3 to be over here. Square root of 28 is just below 5.3 because 5.3 squared is 28.09. Okay, so that's 28. So now let's do 30. Let's change colors for 30. And we're going to continue with 5.4 squared. 4 times 4 is 16, 21, 0, 20, 5 times 5, 25, and 2 is 27, 6, 1, 9, 2. 29.16 is less than 30, so 30 is just a little bit more than 5.4, so I would say the square root of 30 is to the right of 5.4. But if I do 5.5 first and see how close it is, we can estimate where it is in between. And 5 times 5 is 25, carry the 2, so that'd be 27, 0, 25, carry the 2, and obviously it's going to be the same shifted over. 12, 10, 30.28 is 5.5. So 30.28 is only 28/100ths away from that, so this is closer to 5.5. So that would be square root of 30. Done. Okay, moving along, 5.6 times 5.6. 33, 0, 30, 25, and 3 is 28, 6, 3, 1, 3. 31.36, so it's going to be more than 5.6. And then we're going to do 5.7 squared. And it's 32.49, which is more than 32. So the square root of 32 is between 5.6 and 5.7. So I would say maybe here. Okay, it says approximate location. I'm not going to go out to hundreds and get more accurate. Square root of 32 is somewhere between 5.6 and 5.7. And it's almost equal, a little bit closer to, let's see, 32 is 49 100ths away, and this is 64 100ths, so it is a little closer to 5.7. Okay, moving on to the next one, 5.8 squared. Is 33.64. 33.64, we've already done 32, we're looking for 35. 33.64 is less than 35, so it's not less than 5.8, so we now know that the square root of 35 is more than 5.8, but is it more than 5.9? So the last number I'm going to do is 5.9 squared. And I really don't need to do it. I know now that the square root of 35 is between 5.9 and 6.0, but I will do it to see what it's closer to. 9 times 9, 53, 0, 45, 29, 1, 8, 4, 2, 4.81. Is that right? 9 times 9, 81. 9 times 5 is 45, plus 8 is 53. 0, 9 times 5, 45, 25, 29, and 1, 8, 9 and 5 is 14, that's a 34. 34.81. 35 is really close to 5.9. It's only 9.19 away, so that would make me move this closer to 5.9. Okay, so there it is. We approximated the locations of these square roots on a number line in tenths. All right, number 30. Challenge. Which number is larger, square root of 5 or the cube root of 11? Square root of 5 is greater than the square root of 4, but it's less than the square root of 9 because, so now we know it's between 2 and 3. The cube root of 11. Okay, so what times itself 3 times is 11? Okay, so I'm going to do this one a little bit differently. If we scale them both up equally, if I double something or triple it or take it to a different power and I do the same to both, then you're going to get the same answer, just scaled up. And we're just looking for which one is bigger. So if we scale both of them up and then we see which one's bigger, then we know that the initial values would be the same order on the number line. So if I took the cube root of 11 and I cube it, I get 11. But I can't take a cube root of a square root. That's just going to be difficult. So I can take the product of the two. 3 times 2 is 6. So if I just simply take my indices, my indexes, remember this is a 2 and this is a 3. 2 times 3 is 6. So if I take the 6th power of both, watch what's going to happen. Okay, I'll do the square root of 5 first. So if I take the square root of 5 and I take that to the 6th power, well, that just means the square root of 5 times the square root of 5 times the square root of 5 times the square root of 5. Okay, Well, the square root of 5. The square root of 5 is the same as 5 to the 1/2 power. It's our index over our power. So this is a 1 and this is a 2. So that's equivalent to 5 to the 1/2. And if I take 5 to the 1/2 to the 6 and we use our power rule, that is the same as 5 cubed, which is 125. Now if I do the same thing for the cube root 11, cube root of 11 to the 6th power, the cube root of 11, that means, well, this is a 2. I'm sorry, no it's not, it's a 1. The cube root of 11 is 11 to the 1/3. You take your power over your index. Well, 11 to the 1/3 to the 6th power is 6/3 or 2. 6 divided by 3 is 2. So that's equivalent to 11 squared, and that's 121. Well, 125 is greater than 121. It says which number is larger? Okay, well, the square root of 5. The square root of 5 is greater than the cube root of 111, because if I take the 6th power of both, 125 is greater than 121. Okay, what did I write here? This is 11. Okay. Number 11. A certain chessboard is being designed so that each square has an area of 3 square inches. What is the length of one edge of the board rounded to the 10th place? So they want to know this. But I know that each square, each one of these squares equals 3 inches squared. So that means that if this side is x and this side is x, okay, x by x, then I know that x squared equals 3. Okay, so in order to solve for that, we take the square root of both sides, and x equals the square root of 3. Okay, and there are 1, 2, 3, 4, 5, 6, 7, 8 squares of equal length that are all the length of the square root of 3. So therefore this side equals, so s, the side of the board, equals 8 times the square root of 3. And if we approximate the square root of 3, like we've been doing, the square root of 3 is greater than the square root of 1, but it's less than the square root of 4. Right? Because 1 square root 3, no, that's not right. That'd be 2. I'm going to change this to a 9. Okay, the square root of 3 is greater than the square root of 1, but it's less than the square root of 9. The square root of 9 is 3, the square root of 1 is 1, so the square root of 3 is between 1 and 3. Three is closer to 1 than it is 9. It is, the distance from here to here is 6. The distance from here to here would be 2. So I'm closer to 1. So I'm going to try 1.2 squared first. And that's 1.32. And then I'll do 1.3 squared. .69. So these are both less than 3, 1.3, 1.6. So we're way to the left too far. So let's try larger numbers. Hello, eraser, please. Okay, we'll try larger numbers. Let's try 1.5 squared. Well, 1.5 times 1.5 is 2.25. That's less than 3. 1.6 times 1.6. That's still less than 3. So we're working our way to the right now. So we know that 1.3 is more than 1.6. So let's move this over here and try 1.7. Still less than 3, but we're getting closer. So I know that 3 is more than 1. Square root of 3 is more than 1.7. So we'll try 1.8. And finally, we are between these two numbers. Okay, so does it say where to approximate out? Round to 10th place. So we have to go out to the 100th. So now I know 1.7 is less than the square root of 3, and the square root of 3 is less than 1.8, because 3 is between 2.8 and 3.2. Okay, so I need the next decimal place. So let's start low. Let's try 1.72 times 1.72, and that'd be 4, 14, 3, 0. .9 is less than 3. So I know that the square root of 3 is greater than 1.72. So now I'm going to try 1.73. Let's move this over here. .73 times 1.73, 9, 5, 3, 7, 1. Whoops. Skip the 7. 7 times 3 is 21. 49 and 2 is 51. 7 and 5 is 12. 0, 3, 7, 1. 10, 6, 14, 4 decimal places. Okay, went a little too quickly there. Forgot my 0. 7 times 3 is 21. 49 and 2 is 51. And 12. 0, 0, 3, 7, 1. 9, 2, 9, 9, 2. So it's 2.9. .992, so it's 1, so it's not the 1.72. We now know it's greater than 1.73. So let me move this over here. And we're going to do 1.74. Okay, so 1.73 is 2.99, 1.74 is 3.02, so now I know 1.73 is less than the square root of 3, is less than the 1.8. 1.74. Okay, so now this is like 1/100th away, and this is 2/100ths away. So let's use this as our approximation. And it says round to the 10th place, so that'd be 1.7. So I'm going to take 1.7. That's my square root of 3, by the way. So now we're approximating the board. So now we're finishing this equation right here. So now I'm going to say S equals 8 times 1.7. Let's use parentheses. And I should use an approximation because we did round. 7 times 8 is 56. And 8 and 5 is 13. So the board is approximately 13.6 inches in length on one side. Now I'm going to point something out here as well. And where you round matters as well. So I rounded before multiplying, but what if I round after I multiply? How much would that change? So I got my answer to be 13.6. But what if I use this whole 3 and said 8 times 1.73? 8 times 3 is 24. 7 times 8 is 56 plus 2 is 58. And 8 times 1 is 8 plus 5 is 13. So now I have 13.84 rounded to the 10th now, and I get S is 13.8, where before I had 13.6. So you're going to get a more accurate answer if you use the number you found and then round on your last step. So let's do that. The answer is 13.8 approximately. Okay, that is the end of lesson 13. Review this lesson summary and go to your problem set.